sorry? Yes. I was doing other things. I don't believe it. Can one of you here? I wasn't here. So I was here. That's 2 years ago. I was in Morocco. But I was here for a bit before I went to Morocco. Harrison went back to Paris. Nice.
All right. Okay, I'm live. Thank you. All right, good afternoon, everybody. Yes, it is afternoon. And welcome to this session. I'll be talking a lot about what we are doing in verification space and how we look at this, the entire system, okay? We're living in a very interesting era where the change is happening at a very rapid pace. And I'll give you some data points to actually notice this change, because sometimes the change is so rapid that we don't notice it. And today I'll give you some data, hopefully stir up some thinking, and hopefully make your 30 minutes worthwhile here, okay? Okay, so what's happening today? It is an interesting shift that we actually see, where the traditional methods of verification, which were rule-based, database-based, and things like that, are not going to scale anymore. And let's talk about what we are up to at this point. If you look at some of the data that we have seen in the recent past, this is 2024, by the way, only 14% of the chips are actually experiencing the first-time silicon success. And you know what? FPGA is no different either. That means the complexity of what we are managing at this point is way beyond our reach. If you look at time, the time to market, the pressure that we are in at this point, 75% of our chips are actually behind schedule. That basically means we don't have enough time. And then, to make the matters worse, we don't have enough people either. Today, it is estimated that 80% of our demand in semiconductor industry is unmet. We are not producing enough professionals, we are not producing enough skill sets. The universities are not producing enough students. We need much, much, much more than what we have today. So complexity is pretty bad. We don't have enough time, and we don't have enough resources, okay? Talk about the problems. So let's talk about the trends that we actually see in the market. So if you're at my age at this point, most of us actually probably studied, at least I studied in engineering, where I didn't have access to the computers that I have now on my palms. We had one computer shared by 50 people. If you look at our evolution of mankind in the last 100 and 150 years or so, you will see we were driven by automation of physical labor, that we call it as electrification era. Now we shifted to computation because that's where the information and our ability to process data became important. So that basically means, if you look at the doctors who have been in the industry right now for the last 20, 25 years working, the chances are when they studied their medicine, they didn't have computers as a part of their coursework. Okay? So we shifted to the computation era, and now we are actually going to what we call it as cognification. So we delegated our physical labor to something else using electrification, and now we're going to delegate our thinking to someone else. And that's the cognification area that actually marks a very important shift in how we deal with the world to come. So if you look at the semiconductor industry, there should be no surprise that the AI component of semiconductor industry is going to dominate, and by 2030, we're supposed to cross $1 trillion market, and majority of them is going to come from AI. Now, if you look at the generative AI part of it, it's no behind either. It has a whopping 85% CAGR by 2027 that includes infrastructure services and software. So we have AI dominating semiconductor, we have generative AI, a very big component of it, and with data comes security. If you look at just 2023 data breaches, there are 8.2 trillion breaches that happen in the world just in 2023 alone. And now, if you look at the amount of money it costs to fix this and address this, $4.5 million per data breach. If you're like me, I get this letter in my mail every few weeks or so about your data got exposed because you had a credit card from this vendor, and then we'll give you 1 year free of ID theft monitoring systems and things like that. But this is at a scale which is really mind-boggling. 3D IC presents another shift. With the monolithic ICs, we were actually trending at 200 billion by 2030. 3D IC is going to make it 1 trillion. And with 3D IC, all the aspects of heterogeneous integration, interconnects, the size, the complexity, the power, the thermal effects, everything is going to basically be exponentially more larger and complex. So what's not working? If you just take a look at our traditional way of managing verification with all the trends that we are actually exposed to at this point, they are not going to be sufficient. Because our age-old, systematic, standards-driven, rule-based driven verification with disconnected flow, where we looked at simulation, the formal and the static, in a very isolated space, it's not going to be enough. In fact, our whole approach of sort of showering our designs with all kinds of test benches is not going to yield the effectiveness that you're seeking for. Our coverage reports are going to be just numbers, guys. They will not actually have the effectiveness that you seek, because the wisdom is going to be in the insight, and the human brain may not be able to scale what is needed to really give you the confidence that the chip you're about to tape out is going to come out right. Okay? The manual debug overload, it's a very interesting area here. It's like, if you look at the total workforce today, just in the verification space, we have actually done surveys where 40% of our bandwidth at any given point of time across the world is debugging problems. That basically means something went wrong, you expected something else, and you're trying to debug it. 40% of our workforce is invested in finding issues that actually something has gone wrong, whether it's a design or a tool. And our planning is very fragmented. Okay, we are in a global, pretty much all our customers across the world are global organizations. And when we basically are trying to coordinate the workforce across the globe, the specs, the design intent, the plans can very easily go out of sync. And when they go out of sync, the expectations kind of are out of sync as well. And then we don't know what we are trying to accomplish, and the success of our verification is a function of who we are talking to. So is this broken world in isolated tools, processes, and people, this verification is not going to work. Okay? So what's the solution? What are we looking at here? How at Siemens EDA, or any EDA vendor for that matter, is looking at the approaches to solve the verification problems. And we believe AI is going to basically provide you those insights. Now, there are different aspects of AI here. One is leveraging AI to transform the design cycles. We cannot be looking at verification as the traditional way to do that. The shift from finding bugs to preventing bugs. What we do here is basically look at design correct by construction. One of the big trends that we're starting to observe in the industry right now is, the companies are needing, because of the global workforce pressure, companies are needing designers to do much more verification. That means design and verification is going to converge more and more. That means people are naturally going to be tempted towards making things correct by construction. And then the shift from a static process to, our approach was, this is my way of doing it and everybody has to adapt to it, has to basically shift towards fit-to-purpose approach towards verification. So what is going to happen here is basically with AI, we are going to look at AI to do various things for us. We are going to look at AI, and I will show you some of the examples on exactly how this actually works, but automation is number one thing that AI will provide. It will shift the manual labor from people to technologies, and that's the automation I'm talking about. Second is prediction. With AI's predictive analytics ability, we will be able to actually leverage what we have done in the past to predict the future, so that some of your workforce, some of your work, some of your tasks, some of your processes may become much more lenient and lightweight. And then iterations, trying to learn something from the past and applying it to the future will fundamentally reduce the number of iterations that we have in our processes. So how is this going to work out? If you look at this verification itself, the concept of smart verification, we actually look at this in 5 different places. Smart creation, where we are actually creating designs, we are creating netlists, we are creating infrastructure, we are creating test plans, we're generating something that actually fundamentally using AI to accelerate this. Smart regression means this is an ability to basically manage your regression loads, and the focus here is cost. Smart analysis, you have a lot of data that you have generated in verification spaces. Coverage is a very large scale data. And then we are looking at some insights into that data to make decisions. Smart engines is where AI is actually sitting inside your products to provide that acceleration and scalability that you look for to manage your verification workloads. And then smart debug, something has gone wrong, can we apply AI to be able to do that? But fundamentally, what is happening here is, traditionally, when we were looking at EDA tools to be just scalable and fast, we are now shifting our focus from just performance to end user productivity. And we define this end user productivity as a function of either faster engineers, faster engines, or fewer workloads. Faster engineers by automating and making them more efficient. Faster engines by making your products and the tools faster, and fewer workloads where we actually optimize your processes and the need for your processes to basically be minimal. Okay? So let's see this in action. We talked about a whole lot about exactly how smart verification works, how AI is important and stuff. How about giving some pieces of this? Okay? So let's look into the first part. Here is where we are actually generating something. How about take a spec from you? Okay, so property assist is a way where we actually, are actually allowing the users to provide a simple plain English, and we are going to take that English, that circuit condition that is described as a plain English, and convert that into a classical system log, a standardized system log, a property that can be readily evaluated and processed by our formal verifier. Now, here's a cool thing. You don't need to learn system Verilog to be able to write a property like that. We have taken the input from your English, and we have given you the ability to put that in your netlist as well. But what happens if you don't want to provide us with that English language? We are actually going to read it from the PDF document. Now we are reading directly from your design spec, a circuit condition or an operation, and giving it to our GenAI engines, and actually creating that system log assertion that again can be fed into our formal engines. That basically means you created from a design spec, which hopefully was your single source of truth, converted that into a property, and we applied the engines and put that directly in your netlist. And the same PDF can be used to create your test plan. So you have a test plan being created, you have system log assertion to be created. We can map the two, where you as humans are actually most related to the spec that you created. Everything else is fully optimized. This is a simple example of a generative AI, and if you want to know more about this one, please stick around to our booth and you will actually see more about this. How about the next one, debug? Something has gone wrong, and we're trying to figure this out. So let's take look at the application of an AI to be able to do that. And a simple way to look at this one is like taking your regression and convert it into a smart regression. Now look at the smart regression is smart debug and smart regression. We enable that, and now we're running this. The first thing this will do is going to prioritize your test benches. We want to order your test cases in a way where we want to have your regression fail as quickly as possible, because we believe that when we are able to fail them, you actually have not going to invest too much of your resources. We are going to shift our focus on debugging very quickly. When stuff fails, we are going to cluster your issues. We're going to pick up the biggest cluster that you have. We're going to look into why this particular thing failed, which modules were changed, and then map it back to the specific design commits that resulted in that failure. So we made your regression to fail quickly. We clusterized your regression failures. We mapped it to the design changes that resulted in those failures. And now you have the final 2 or 3 commits that actually result in those changes. You went from actually running the regression, saving your server or hardware time, to finding out the commits, the guilty commits that you have. That's AI, that's the power, and that's generative and analytic AI that we are talking about here. So the last one is the analytical AI. So this is where you're actually having a large amount of data. This is where you're actually working with coverage analysis. And then when I made a statement there earlier that just data is not enough, you have to find insight. And one way to look at this one is basically looking at a very large scale data that your regression analysis have created. Now you look at this, you have a whole bunch of data created. We are looking at creating these graph trees to basically find out what is your common expressions that actually need to be covered in the coverage. We actually find out the commonalities, we create those graphs, we identify the common expression patterns, and now you have in front of you, this is a fully configurable view where you are able to find out exactly which are those expressions that need to be touched or covered in your coverage analysis to have the biggest impact of your coverage quality. Okay? And when you have that, when you find that out, you can actually do this assessment about exactly what kind of test benches you need to write to be able to cover more. And not only that, when you have this cross coverage gaps or holes, we're able to identify and then present that to you. So we went from, oh, I just have 60% coverage, I just need to throw some test benches at my design in the hope that my regression will actually improve. We went from that to this, where we are actually making some informed decision based on the analysis that our analytical AI was able to produce. And that's the power of AI that we want to present to our regression, to our verification community. Finally, we totally believe that traditional way of looking at things will not work. There's a lot of talk about AI, there's a lot of talk about its application, but one of the biggest things that we need to demonstrate in the verification community here is our ability to adapt. Our mindset has to change. We require a smarter approach. We have to question our traditional methods. We have to question our siloed approaches. We have to question our static processes to be able to do that. And we believe Costa One is our approach to answer the smarter verification by providing connected, where we bring in the applications and flows from all different domains together, data-driven, where we find wisdom in the data, and scalable, where we fundamentally basically make our products and tools much faster and high capacity to be able to find manage the verification load. And we have demonstrated this fairly well enough. Costa One is our smarter verification approach. It's our promise of innovation. It's our promise of adaptability. It's the value that we are delivering to the verification community. That's all I had. Thank you so much. I'm open to the questions if there are any.
If you have a question, we have 2 mics in the aisles. You can step up to the microphone. All right, if there are no questions, I'm sure he will be happy to answer questions to the side of the stage. Thank you very much.
Thank you.